Now I want to look at some special sums that you might need for calculus. So the first one I want to look at is the sum of a constant. So if this c here is some constant, so we're just adding it up, and we're adding it up n times. So what would this look like? So this is a pretty simple sum. So this is the sum that goes from k equals 1, that's where you start, up to n, that's where you stop, of a constant, and this n is some positive integer here. So this would look like just a bunch of constants added together, like you can see up above. And the dot 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 means keep going up until the last one. And how many times do we do this? Well, you're doing this n times. So that's n of these constants added together. Well, if you have n constants added together, that's the same thing as n times c. And so that's the first summation formula that I want to introduce here for special sums. The next one I want to look at is the sum from k equals 1 to n of k, which would just be 1 plus 2 plus 3 plus 4 plus 5 all the way up to n. So to get a formula for this one, what we can do is we can write out the sum here. So this is the sum from k equals 1 up to n of just plain old k, and that's going to be 1 plus 2 plus 3 plus, and then we can do dot 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 all the way up to, and then we would have n minus 1, and then n would be the last term. And what I'm going to do is I'm going to write this again slightly differently here underneath. So this is the same sum, and this time I'm going to do it in reverse. I'm going to start with n and count down. So I have n, and then I would have n minus 1, and then I would have n minus 2, and so on. So then dot dot dot, and then I would have 2, and then 1 would be the last one if I'm counting down in reverse. And so now what I'm going to do is I'm going to add these vertically. So when I add these two sums together, I get 2 times the sum from k equals 1 up to n of k, and that's going to equal, and I'm going to have n plus 1, and then I'm going to have 2 plus n minus 1, well that's the same thing as n plus 1, and then I'm going to have 3 plus n minus 2, well that's the same thing as n plus 1, and in fact all of these terms are going to add up vertically to give n plus 1. So 2 plus n minus 1, that's the same thing as n plus 1, and then of course at the end I have an n and a 1, that makes n plus 1. And how many of these terms do I have? Well, I have n of them. So there's n terms here, so that's really the same thing as n times n plus 1. And so to get the sum, all I have to do is divide the 2 over to the other side. So I would get a formula that looks like this. Now I want to look at the sum from k equals 1 to n of k squared. And so that would be 1 squared plus 2 squared plus 3 squared all the way up to n squared. And to get a nice formula for this, you have to use a little bit of a trick. So here's the trick. So you know that x plus 1 cubed minus x cubed, if you were to multiply all that out, so multiply out the cube here and then subtract the x cubed. If you were to do that, you would get 3x squared plus 3x plus 1. Okay, so you might not see right now how this is related to this, but I'll show you here in a second. So that's the first thing to note. So we're just taking x plus 1 cubed minus x cubed. And I'm going to look at this for a bunch of different values for x. So we'll look at it for x equals 1, for x equals 2, for x equals 3, and so on all the way down until we get to x equals n. And so we're going to do something similar that we did with the other formula where we're going to write all this out and then we're going to add vertically. So for 1, well 1 plus 1 is 2, so this would be 2 cubed minus 1 cubed equals 3 times 1 squared plus 3 times 1 plus 1. Now for x equals 2, this would be 2 plus 1, so that'd be 3 cubed minus 2 cubed equals, and then I would have 3 times 2 squared plus 3 times 2 plus 1, okay? And then I have for x equals 3 plus 1 is 4, this would be 4 cubed minus, and this would be 3 cubed, equals 3 times 3 squared plus 3 times 3 plus 1. Okay, and so then you can keep going here, and eventually you would reach x equals n. And so for x equals n, you would have n plus 1 cubed minus n cubed equals 3 times n squared plus 3 times n plus 1. Okay, this is a cube right here. Okay, now we're going to add vertically. So I'm going to add up all the terms. And so if you look at this side, the left-hand side, well, this 2 cubed right here, when you add all the terms up, is going to cancel with this one here because this is a minus sign. Those ones are going to go away. This 3 cubed is going to cancel with that 3 cubed. This 4 cubed will cancel for the 4 cubed. That'll be right there. And so you'll see that they're all going to cancel pairwise, except for you're going to have 2 things left over. So this one would end up canceling with the n cubed that would be up here right before it. And you're just going to have this term, the n plus 1 cubed, and the minus 1 cubed. So if you add them up, you would get n plus 1 cubed minus 1 cubed. And so that's because they all kind of cancel pairwise except for this one and then this one down here. This we have a bunch of 3's, and then we have 1 squared plus 2 squared plus 3 squared all the way up to n squared. Well, that's the sum that we're actually trying to find. That's the sum from k equals 1. K equals 1 up to n of k squared times 3. If we factored the 3 out, it's a k down there. Okay. Plus 3 times, and this is 1 plus 2 plus 3 plus all the way up to n. If we factor the 3 out of everything, remember we're adding all of these together. So that would be the sum from k equals 1 up to n of just plain old k. And then this is 1 plus 1 plus 1 plus 1 plus 1 n times. So that's the sum from k equals 1 up to n of just plain old 1. Okay, so this sum here, the sum from k equals 1 to n of k, and this sum from k equals 1 to n of 1, those are ones we know already. These are formulas we have figured out already. So we can actually plug in for those and then solve for this sum right here. So let's do that over here. So draw a line right here. So we have n plus 1 cubed minus, well, 1 cubed is 1. I'll just write it as 1. Equals 3 times the sum that we're trying to figure out. That's the sum from k equals 1 up to n of k squared. Plus 3 times, and now the sum from k equals 1 up to n of k, we know that already. And so that was, if you remember, n times n plus 1 over 2. And that was the formula we just had. All right, and then we have a sum of a bunch of 1's. And so if you add up the sum of all these different 1's, there's n of them, so this just ends up being n. All right, now I have just an equation I can use to solve for this sum right here. So if you multiply out this n plus 1 cubed here, so let's see, what's the best way to do this? Maybe I'll do this first. We'll bring this sum over here first. So this would be the sum of 3 times the sum from k equals 1 up to n of k squared, and that's going to equal, so I'm going to have n plus 1 cubed minus 1 minus, and I'm going to subtract these two terms over to the other side. So I'm going to have a 3n times n plus 1 over 2, minus n. Okay. And then I can divide the 3 over here, so I'm going to have just the sum from k equals 1 up to n of k squared equals, and I'm going to have a 1/3 of, okay. So n plus 1 cubed. What is n plus 1 cubed? So n plus 1 cubed is, if I multiply it out, I'm going to have n cubed, then I'm going to have 3n squared, and I'm going to have a 3n, and I'm going to have a 1. And that's going to be minus 1, and I'm going to still have minus, and I can multiply this out too. That's going to be a 3 halves n squared minus 3 halves n minus n. Okay, so I think that's right. Let's make sure I distributed the minus sign here, 3 halves n squared, and then the minus sign again, 3 halves n, when you multiply the 3n over 2 times the 1, and then a minus n. Looks good. Okay, so this sum equals 1/3 times, and now I can combine some like terms here. And I have, let's see, an n cubed here, and I don't see any other n cubed, so I'm going to have an n cubed. How about the n squared? Well, I have a 3n squared here minus a 3 halves n squared. So let's see, what is that? So I have 3n squared minus 3 halves n squared. And I need a common denominator here. So I need to multiply this by 2. So this would be 6n squared over 2 minus 3n squared over 2. And 6 minus 3 is 3. So this is 3 halves n squared. So I get plus 3 halves n squared. Then I have a 3n here, and I have a 3 halves here. And this is the same thing, 3 minus 3 halves, 3 minus 3 halves. That's going to be 3 halves again, so that's plus 3 halves n. And then I have a plus 1 and a minus 1, and I also have another n here I forgot to add in, so I'll have to do that. So let's bring that here, minus n, and the plus 1 and minus 1 are going to go away. Okay, so let's see, what can I do now? I have a 1/3 still out front, so I can multiply that through. It looks like I'm going to have a factor of n that can come out of all of this. So if I do that, let's bring the n outside. Then I'm going to have n squared left over here. And I'm going to have, let's see, 3n left over here. And then I'm going to have I have a 3 halves n minus n. What was that? 3 halves n minus n. That's the same thing as 3 halves n minus 2n over 2. And let's see, 3 minus 2 is 1. This is just n over 2. Okay, but remember I'm factoring an n out of this. There's the n I factored out. So that n over 2 is really just a half. So that becomes a half. Okay, and let's see here. I have, did I do this right? So I should have a 2 here also, right? Okay, and then all of this was over 3. So I'm almost done. I think what we can do is make this a 2n squared over 2 and add all of these things as the common denominator here of 2, and then that would make this a 6 down here. So if I do that, then I would get something that looks like this, all over 6. And I think this 2n squared plus 3n plus 1 actually factors. And if you factor it out, you end up getting a formula that looks like this. And that's the formula for the sum from k equals 1 to n of k squared. And it's a little complicated to derive it. It's not something you would want to derive all the time, but it is a very useful formula, as you'll see, with calculus. Now the last formula that I want to look at is the sum from k equals 1 to n of k cubed. So that would be 1 cubed plus 2 cubed plus 3 cubed all the way up to n cubed. And to get a formula for this, you would actually do something very similar to what you did with the sum from k equals 1 to n of k squared. In other words, you're going to start by looking at x plus 1, and this time instead of going to the 3rd power, you're going to go to the 4th power minus x to the 4th. And when you do this, if you multiply this out, you will get 4x cubed, and you'll get 6x squared, and 4x and 1. And from there, you can do something very similar to what we did with the sum formula for k squared. So I'm not going to go through and do all this out. I think it follows in very much the same way. But eventually, if you were to solve all this, you would get this formula right here. So a good way to remember this kind of looks like the formula that you had when we just looked at the sum from k equals 1 up to n. 1 up to n of just plain old k. And that was, if you remember, that was just n times n plus 1 over 2. So this looks almost the same, except we're taking that n times n plus 1 over 2 and squaring it. And that will give you the formula for the sum from k equals 1 to n of k cubed.